Hi, my name is Nicholas Espinal. This is the 8th question for my Chapter 25 quiz, and this is what it asks. The diameter of a 12-gauge copper wire is 0.081 inches. The maximum safe current it can carry in order to prevent fire danger in building construction is 20 amps. At this current, what is the drift velocity of the electrons? The number of electron carriers in 1 cubic centimeter of copper is 8.5 times 10 to the 22, and the charge on each electron is 1.60 times 10 to the negative 19 coulombs. So to answer this question, we need to first understand how is drift velocity related to the quantities that they gave us. So we know that current is equal to N, the number of charged particles, times Q, the charge of each particle, times the drift velocity, and all of that multiplied by A, the area of the wire's cross-section. So solving for the drift velocity, we find that the drift velocity is equal to the current divided by the number of charged particles times the charge of each particle times the area of the cross-section of the wire. So to find the drift velocity, we're just going to need to plug in each value of each quantity and we'll get our answer. So the cross-section of the wire is what we see here, where D is the diameter of the wire, and that area is going to be pi times the diameter squared over 4. So since we have the drift velocity is equal to the current divided by N times Q times the cross-sectional area, we can just input our formula for cross-sectional area into our drift velocity equation, and we're going to get this. Simplifying it, we'll get the drift velocity is equal to 4 times the current all over N times Q times pi times the diameter squared. But first, we must make some conversions. They gave us the diameter in inches and N in centimeters. We're going to need both of these in meters so we could have a completely uniform measurement in what we're about to calculate. So we're going to convert inches into meters using this simple conversion, 0.0254 meters in 1 inch. And then we're going to get this value. This is the same value for the diameter, just in meters instead of inches. And next, we're going to get N, which is in particles per cubic centimeter. We're going to convert this from cubic centimeters to cubic meters. And we get this new value for N, which is still the same equivalent value, but now in meters. So now we have this equation, the drift velocity, and we need to ask ourselves, okay, do we have all of the variables that we need? So we have the current, they gave that to us, 20 amps. We have N, which we just converted from centimeters to meters. We have the charge of each electron, which they also gave us. We also have pi, which is just a constant. And we have the diameter, which we also converted. So now we just have to plug in values and we're going to get our answer. So we plug in everything here. We plug in the current, N, Q, and the diameter squared. And we're going to get the drift velocity is 0.0004423 meters per second. Now, this is a very small value for meters. We can convert this into something that's easier to write down. We can convert it into millimeters per second. If we just move the decimal place 3 places to the right, we'll have our unit in millimeters per second. So bringing it down to 2 sig figs, we have the drift velocity is 0.44 millimeters per second. So we look at our answer choices here, and we notice from what we see when we got our answer, we see that it is answer choice D. So by using that current formula that includes the drift velocity, we can solve for the drift velocity. And if we're given the rest of the quantities in that equation, we could find the drift velocity very easily. Thank you.